Hello all, my name is Jared Keim. I am an instructor at Thaddeus Stevens College of Technology. And today we are going to look at manufacturing a part that was designed by students at Hempfield High School. This is our first coordinated video with Hempfield High School. Mr. Shelley was kind enough to send over this solid that the students had designed. So today we're going to take a look at manufacturing this part, some things that we can do to maybe save some money on manufacturing, the process that we're going to use based on the form, fit, and function of the part. So we're going to talk about all that stuff, and what we're going to do is we're going to look at it first. We're going to program, we're going to create code for a CNC machine. And then we're going to go out to the machine and we're going to take more video of maybe setting up the machine and actually the part running itself. So let's go ahead and dive in. All right, so as you can see, this is an IPT, which is an Autodesk Inventor file. It is a solid. So what I'm going to do is I'm actually going to drag this solid into another software that we call CAM software. Obviously, Inventor is a computer engineering software, computer-aided engineering software, whereas this is a CAM software, computer-aided manufacturing software. This will allow us to create code to put in the machines, M&G code to be exact, to put in the machines so that the machines know what to do and how to make the part. So what I'm going to do is I'm going to start by importing this. I'm going to hit Open. And I'm going to go to my file, AutoCAD, oops, not AutoCAD, I want to do Inventor. And of course it opens that. All right, and there is our file. So it brought it in, everything looks good here. I don't see any major problems with the solid. It selects the solid. You always want to check, to make sure that everything comes in okay. All right, so the first thing I'm looking at here, when I look at this part, before I manufacture it, I want to think about a couple things. What is the form, fit, and function of the part? Well, in this case, it's a pencil holder. So form and fit, really not really much going on there. I mean, the only real thing that needs to be a fit will be pencils need to fit in here. So the tolerance of these holes, while it's very loose, they do have to accommodate pencils, right? So I believe these holes are 3/8, and we can double check that. Let's analyze an entity. Check that. They're a little over 3/8. No, they're actually a little under 3/8. But we can make them 3/8 because we know all it needs to do is hold a pencil. So if they're 375 instead of 359, that should be just fine. So that's really my only form and fit that I need to worry about. The only thing that's critical, I should say. Now, function is something entirely different. So what is the function of this part? Obviously, it's to hold pencils, but what else? It needs to be aesthetically pleasing on the desk, right? It has to look good. It should be shiny, or it shouldn't be all scratched up and dull. It should look really good. It should look attractive because it's a showpiece. So what that means is I need to take a look at this, and I'm going to go back to my top view, and I want to see what size this is. So I'm going to analyze an entity again and analyze that line. Okay, so it's 3 inches long, and I'm going to go ahead and assume, but I'm going to double check, of course, that is 3 inches. So it's 3x3 material. All right, so let's rewind a step back to design. When designing something like this, it's always good to think about form, fit, and function. That should be the number one thing that you're thinking about when designing it. So if we know that this part is going to look good, we need it to look good, but it doesn't really matter if it's 3 inches or say 2.95 inches. So say it's 50 thousandths of an inch smaller all around than what it is currently drawn at. Well, that's not going to change the function of it, right? It's not going to change fit. It's not going to change. It's going to change the form a little bit. It's going to change the size, but that doesn't matter. So if I'm drawing this part, I'm going to try and think about that, because right now, if I need to make this part a 3x3, if I need to make it 2 spec, then I need to order material that is larger than 3x3. So I have to order 3¼ by 3¼ if I can get that. More likely, probably 3½ by 3½. So basically what I'm getting at is you could save material by making this and forming it a little bit smaller. It'll still work just the way it does now, but you would save that material. Now, that might be 10 cents of material, might be $1 of material. But think about over 10,000 parts. If we were making a large quantity of these, 10,000, and say it's $1 per piece of material, that's $10,000 you just saved across the job. So just something to think about. Now, this part I did not design. So what that means is I need to make it to spec. So I have 3½ by 3½ material, and we're going to make this 2 size 3x3. So now, in terms of manufacturing, when I think about this, well, if I had 3x3 material, I could have, and I didn't bring this up before I should have, you're probably thinking, well, why can't you just order 3x3 material, shave this angle off, put the holes in, and you're done? Well, we said we wanted to look aesthetically pleasing, right? It's got to. That's the whole point. It's a showpiece. So that means that I want to mill all sides of this. I want to make all sides shiny, milled face. It needs to look good. So that's why I need to use larger material, which also tells us how we're going to manufacture it. Since we've decided that we're going to mill every face of this part so the whole thing looks good, doesn't have the dull stock finish, that means that we have at least 6, 7 setups here, right? Because we have 7 faces. We have 1, 2, 3, 4, 5, 6, and then our engraving face would be 7. So we have 7 setups here, potentially. Well, when I get to that many setups, chances are I'm not going to use a 3-axis mill. Unless that's all I have, of course. Then I would use a 3-axis mill. But we have the technology here at Thaddeus to make this in a 5-axis machine, which we can reduce those amount of setups down to 3. And in those 3 setups, only 2 of them actually affect the size, fit, form, and function of the part. So, we're going to set this up at a 5-axis. So the first thing I'm going to do is, in the 5-axis, generally what I do is I use the very center top face of my part to create my 0. So my 0, 0 is going to be in the top center. So what I'm going to do is I'm going to create a bounding box. And first, I'm going to make sure I'm in 3D mode down here, because if I don't, it will not create a bounding cube, it will create a box. And select this and selection. Okay, so there is my cube around the part. And in the options I have in here, I can actually do face center points. And I'll click off lines and arcs. So I have lines and arcs on, now I'll just make lines and arcs on all the edges around the box. I don't want that. So we go ahead and hit check. And you can see there I have center marks in all 6 faces. So it just gives me points on the center. All right, so what that'll allow me to do is I can now transform that. And I'm just going to transform. Actually, I could just do move to origin on this one. And select that point. And you can see there, it has now put the center in what I want to be the top. Now, you might wonder, okay, well, couldn't I make this the top? Yeah, I could. But this one gives me access to all the sides that I want. The bottom face is going to be the face that I can't reach. That's going to be the face that I have to hold in the vise. Since that face is just flat and all the other sides around it are flat, all the adjacent sides, then it's not as critical, right? If I made this the bottom, well, I have some real issues there because I'm gonna have trouble getting to this to engrave it. So you have to think about, you know, what side you want to make your bottom, or the side that you hold in the vise, and it's going to be your least critical side. In that case, it's this one. All right, so we've got that located correctly. I'm just going to get rid of these points. So I'm going to select all points and just hit delete to get rid of those, since I used them for what I needed, but I don't need them anymore. All right, so now that we have it set up correctly, the next thing I'm going to do is I'm going to select a machine. I'm going to go to my mill. I'm going to go to, I have a 3-axis mill and a 5-axis. We're going to use our 5-axis. And I need to set up my stock. This little thing right here, this red dotted line, is actually the stock. That's telling me what size of raw material do I have. So we already kind of discussed part of that, 2 of the dimensions. So we know that the Y dimension is going to be 3.5. Oops, not 35. It's a lot larger. The Z dimension is going to be 3.5. Now, you might be thinking, wasn't it the Y? Well, no, because the Y, or the, sorry, isn't it the X? The X is actually going to be the length of our material. So I know that the length of this is 4 inches. I know that because I've already measured it before this video. But if I didn't know that, I would have to close out of here, and I would go and I would check that just to make sure it was actually 4 inches. So if I did that, I just go Analyze Entity, and it's 4 inches. So you can see here, one other thing that I need to do here is I'm going to create, well, I'll create a plane afterwards. So let me create a plane. And I'm going to call this Dynamic. I'm going to make sure that I'm actually on my gnomon. My Z is going to be positive. And my X will be -90. All right, so that's oriented the correct way, the way that I want it. So you can see from this that if I look at it, my Y value is 3 inches, 3.5 inches for my stock. My Z value will be 3.5 inches, and my X value is going to be that 4 inches. Okay, so we're going to call this plane 5-axis top. And I'm going to hit check. And I'm also going to work on that plane. So I'm going to set everything so I'm working with that plane. And now I'm going to go back. I'm going to create my stock. I'm going to select the correct plane for my stock. Check. And my Y is going to be 3.5. My Z is going to be 3.5. And my X, I'm going to make that a little longer than 3 inches just so I have some to shave off. I'm going to make it 4.125, which is 4 1/8. And my stock position, 0, 0, is in the center, top. And that is exactly where it's at, so that looks good. So let's make sure that this actually lines up correctly. And that looks good. So you can see our stock. Front, right side. So our stock looks pretty much evenly divided all around this part. Now, the one thing you can see is this lines up perfectly with the top. I'm actually going to shift it up 10 thousandths just so we can see the face pass that we're taking off the top. Since it's right on the top edge, it won't show it when we simulate it. So I always move this up 0.01. Check. And you should see that shift. There you go. So it shifts up a little bit. All right. So that looks good. Okay, so the next step is to create planes for all these sides. So I have to create more planes. To do that, I'm just going to come in here just the way I did the other one. And I'm going to start with the back plane, and I'm going to work my way around. I'm going to go I'm going to go clockwise around the part. All right, so we're going to create a plane, dynamic, And of course I need to orient this correctly. So I'm going to go negative 90. And this one here, I can snap to there. And that plane is oriented correctly. So I'm going to call that one 5-axis back. Check. All right, the next one will be this one here. And I'm going to create a new plane, dynamic. And I'm going to set it down here, but I'm going to translate it up. So first, let's get it oriented correctly. So let's bring this one to 90 point. And let's swing this around to there. All right, so that's oriented correctly, but I really kind of want it up in this upper left-hand corner. That's the standard that I generally always use. So what I'm going to do is I'm going to select this, and I'm just going to bring it up to there. And that clicks it in place. And we're going to call this 5-axis. And this is going to be the right side. Right. I had to think about that a second. Helps if I spell right. There we go. Okay. Check. All right. So I'm going to fast forward through the rest of these. You'll be able to see them, but I'm not really going to do any talking. I'm just going to fast forward through them to get this done. Okay, so we have all of our faces. So we got all of them except for the bottom, but we don't need the bottom because we can't machine it because that's where it's holding in the device. So we should have 6 faces total, 1, 2, 3, 4, 5, 6, and we do, including the engraving face here, which you can see is lined up with that surface. Okay, so now that we have those, we are ready to start applying toolpaths. So if I go into toolpaths, I can go to here, and I'm going to do facing paths for all of this stuff. So we're going to do a face, and ironically, if I don't select anything here, it will actually just look at what the stock size is, and it will face that. And that's what I want to do in this case. So I'm going to go ahead and hit check, and I'm going to select a tool. Okay, I have the filter right. I just need to go to the right tool crib. Since it's aluminum, I pick my aluminum tools, 2.5-inch face mill. We're going to go 150 inches a minute, 10,000 RPM, plunge rate of 30.0. We're going to zigzag that. I'm going to leave 10 thousandths on. Oops. 10 thousandths on the bottom. I believe I'm going to make my across overlap. Let me see what I want to make that. I think I'm going to make that 50. Make that 50. Everything there looks good. Depth cuts. Do I want to take multiple depth cuts? In this case, I do not. Actually, I do want to go back. I want to change this to 80. It's just going to give us a nicer finish if I go slow. I forgot that I'm not roughing this one, so I'm actually going to go to 0 here. I'm only taking 10 thousandths off the top. For the other ones, I'll do a roughing and a finish pass. Linking parameters. It's going to 0. Top of stock is right there. Planes. So just make sure it's on the right planes here. Okay, that should be 0. What tipped me off that it was on the wrong plane was this said negative something. It should be 0, obviously. Feed plane, and actually this should actually be 0.1, 0.1. That's good. Coolant, let's make sure our coolant is on. It is, check. And you can see our toolpath generates there. So that's our toolpath that the face mill is going to follow. All right, so now I'm just going to do the same thing for all the rest of the sides. I'll do one more here with you, and then we'll fast forward through this. Okay, so if I go into face, and again, I'm not going to select anything. Got my mill, it's got all my, it defaults to all the ones I put in previously, so all of this looks pretty good. Zigzag. In this case, I think I actually want to make this 10. And these should be 10 as well. Okay, everything there. Let's go down to put 10 thousandths to leave on the floor, and then we'll take a finish pass. Well, actually, I'm going to do it inside of here. We're going to make this 0. We're going to do depth cuts, and I'm just going to add one finish pass and make it 0.01. Keep tool down. Linking parameters. Top of stock is going to be here plus 1/4 inch. Well, gotta make sure we're on the right planes here first. Plane. And for these, we want to be on our back, 5-axis back plane. Check. Check. Okay. So now we go back to our linking parameters and make sure we got them right. See that 0, so I want to make it 0.25 because remember there's an extra 1/4 inch on both of these sides since I'm using 3.5 material and the finish size is 3, taking 1/4 inch off the front and the back. Okay, so that means that these here, we're going to make these 0.3 and we're going to make these 0.35. And everything there looks good. Check. And you can see there I have my toolpath. So I'm going to go ahead, work through these, and I'll be back with you as soon as I get the rest of these done. Okay, so we have all of our facing ops done, and let's take a look and simulate this and see how it looks. And there may be some errors here, so this is how we check to make sure that we didn't make any mistakes, input some numbers wrong. Gives you an idea of what it's actually going to do. You can see there, that looks pretty darn good. I'm happy with that. Let me slow it down and go through it just a little slower just to make sure. Just facing the back, side, doing the finish, front, finish pass, left, finish pass. And it's cutting the angle on, finishing it, and that looks good. All right. So we have all sides of it finished, or faced, not necessarily finished yet. Okay, so the next thing we can do is we can actually drill these holes. That's what I'm going to do next, and then we'll do the engraving after that. Okay, so I'm going to get rid of those tool marks, or tool paths, and we're going to do these holes. So I'm going to go to level, not levels. I'm going to go to my 5-axis top, hit equals, and make sure I'm working on 5-axis top because that's the plane that I'm using. And we're going to do some drilling. And I'm just going to select these holes and hit check. I'm going to select a tool. In this case, like I said, we're going to use a 3H drill because it's going to work just fine. There's no reason to use an oddball drill when you can just use a standard, basically a nominal size drill. And now I got to find a 3/8 in here somewhere. It's somewhere here. There it is. Check. Okay, we're going to drill this 15 inches a minute, about 3,000 RPM. That's 2.5 chip per tooth. That looks good. Drill counterbore, we're actually going to do a deep hole cycle. That's a tap cycle. Chip break. We're going to do a peck drill cycle. And we're going to do 0.75 to begin with, 0.5 reduction, and 0.125 for the finish. Depth of it, select the bottom of that hole. So we got 2 inches. I turn my tip comp on so it compensates for that. Okay, everything there looks good. Planes look good. Coolant, need to make sure that's on. That is. And there we go. There is our holes. Okay, so let's simulate that whole thing and let's see what we got. All right, that looks good. All right, next we can go on to working on this face. Now to do that, we're going to need to do some editing. We have some complex stuff going on here. We also have some interesting geometry sticking up here. Some kind of got some surfaces that are sticking proud, and that happens sometimes in the translation process, bringing this into a different software. So that's not uncommon. But we're not going to use these solid surfaces to create this. We're actually going to create some geometry here, basic lines, arcs, splines to do this. All right. So first, let's get on that plane. So now that we're working on that plane, we can hit top, and it'll show us a directly view overhead, a bird's eye view of this thing. All right, so what I'm doing first is I'm kind of looking at this and just seeing how I want to do it. So at first glance here, it looks to me like I'm going to do this, all the writing, the engraving, and these outside grooves, this kind of this shield here, this Celtic shield. I'm going to do that all in one operation. And I'm going to do some different operations for some of these things. Just because these don't lend themselves well to, they don't all of these engravings, they don't all lend themselves well to one single operation. Now I try to lump as many as I can into, as few operations as possible, but if they don't really work well, you have to create extra operations. So the first thing I'm going to do here is I'm actually going to create some geometry. So what I'm going to do is I'm going to first create a level. And this is just like levels in AutoCAD. I'm going to call this engraving geometry, and we're going to work on that level. And we're also going to create curve on all edges. And we're going to pick this surface. We're going to pick all the top surfaces here. And I'm going to do some interesting stuff in here. That looks good. That looks good. Okay, everything there looks good except for the book. So when you bring that, and that. So that'll get the book. And then for this tower, you can see we have multiple steps here. So I have to decide what's going to give me all my lines. I'm actually just going to pick everything just to be certain that I'm going to get everything I need. We go to top. Okay, so I should have everything I need there. Now, in theory, I should be able to unselect these, and they should be given to me default through the fact that you can see that, this outline here and this, the combination of those two would make this, would give me that geometry. But I'm going to select that anyway because it's going to make it easier to chain later on. And that's just something you learn from using this software over time. All right, so I'm going to hit End Selection. And you can see there, it put a bunch of geometry, created a bunch of geometry on those edges. And check. And we have 1,046 entities were created. All right, so I'm going to turn off the solid now. I'm also going to delete this outline because it did create edges on that surface, so I don't need those. So right there, now we have our emblem, and as you can see, it doesn't necessarily create it all on the same Z level. So you can see the stuff that was a little bit deeper in the tower particularly, it created that down on different levels. So the first thing I need to do is bring that all up to the same level. So in order to do that, I'm just going to select it, and I'm going to go to my transform, and I'm just going to do a projection. I'm going to project it to 0. And hit check. And actually, I want to undo that. I think I copied it by accident. One of the things that kind of gets on my nerves, it always defaults to copy instead of move, which annoys me sometimes because I move things more than I copy them. So now, if I go to a front view, you can see there everything is on the same Z level, and that's what we want. All right, so now that we have everything on the same Z level, I am almost certain that there is going to be lines over lines. Now, this creates a problem when we go into picking our toolpaths and chaining different stuff. So what I'm going to do is I'm going to pick this, and we're going to go to a command that says duplicates, and you can see I have 40 lines and 5 arcs. And it's going to delete all those duplicates for me. So now I don't have duplicated lines. The next thing I'm going to do here is I'm going to save this. And I really should have done this probably earlier. Let's see here. Where am I going to save this to? Browse. Pencil holder. 2. Save. Okay. So we've got this saved. The next thing I'm going to do is I'm going to add a run-in that's going to find any overlapping lines. So I have lines that maybe the endpoint, they aren't connected, but they're overlapped a little bit. This also creates a problem in Mastercam when you're trying to chain and select toolpaths. So I'm going to run an add-in that's going to get rid of those. And it's called Find Overlap. Check. Select all of my stuff. End selection. And clean up. So it says 21 overlapping entities were deleted. So that's good. We got that cleaned up. Now, I have no doubt that I'll probably run into some more stuff here, but we'll deal with that. We got us rid of as much of it in 1-2 swoops as we can, and we'll deal with any additional stuff down the line here. All right, so I did say that we're going to do this, these outlines, and Thaddeus Stevens all in one shot. So what I'm going to do is I'm going to put this other stuff on a different level. And actually, I'm going to do these 3, the H, the micrometer, and the book, or in the same op. I'm going to do this one, the tower, in a different op. And then I'm going to do the Thaddeus and all that in yet a different op. So I'm going to actually create 3 more levels here. I'm going to call this... and this may not make sense to you, but it's essentially just a descriptive way of knowing kind of what toolpaths I apply this to. All right. So I guess the easiest things to get rid of initially are probably the roughed engraving. So let's work on that. And all right. All right, we're going to move all that stuff over. Check to roughed engraving. And then I'm going to go to, oops, didn't want to bring that on. Turn that off. I want to go to standard engraving, and I'm going to turn off the roughed engraving just to make sure that that moved. So that did move. And we're going to select this tower. And it's very difficult to get in there and select without this thing jumping. Select that part of it. See how much of this thing I can get. This one's slightly more difficult to grab. I could do a polygon to get it. Okay, so that looks pretty good. Let's move that to standard engraving. Check. And then let's go to roughed engraving. Oops, not roughed, contour engraving. Oh, I messed up. I accidentally moved that to the wrong one. All right, let's bring that back. Standard engraving, select that, and let's move that to the correct one. Contour engraving. Okay. All right, so we can turn off roughed, we can turn off contour. All right, and this will, all the rest of this should go to standard engraving. So now the engraving should be empty, essentially. So now all we should have is standard engraving. If I turn that off, that should all disappear. Okay, so that looks good. All right, so we're going to start with standard engraving. We're going to engrave this stuff. So I'm going to select that, and we're going to do our toolpath, engrave, and we're going to select everything here. Check. Got to select an engraving tool. Our engraving tool is 3/16 by 60 by 1,000th tip. We're going to move that at 10,000 inch or 10 inches a minute at 12,000 RPM. 10 plunge rate, rapid retract on. Engraving. Top of stock, of course, is going to be 0. Depth is going to be, we're going to make that negative 0.05. And make that absolute. These are fine. Filter's fine. Everything there's good. No rough cuts. We don't want to rough this. One thing I do want to check is to make sure that my planes are right. 5-axis engraving. Okay. So this one here is not right. This one needs to be on the 5-axis top. Check. All right. And 5-axis engraving for the other two is correct. All right, let's go ahead and simulate that. Speed this up. And let's turn the tool off so we don't see it. And let's turn the wireframe off and see how that actually looks. All right, so I'd say that engraving looks pretty good. No complaints from me. All right, so let's move on And I'm going to go to my levels. I'm going to turn that one off. I'm going to turn on contour engraving. And we're going to engrave this tower. So if you noticed, I named these basically after the toolpath that I'm using. So I'm going to use a contour for this one. Box it, select a starting point, check. Tool is the engraving. It's 10 inches a minute. And I'm not sure why, but well, actually I do know why. It's a different toolpath. That's why it doesn't automatically populate these fields the way that I left them in the last engraving path. It's because it's a different toolpath. It's a contour rather than an engraving path. All right, so where? I'm going to turn this off. 2D contour. No stock to leave. Depth cuts, no. Lead-ins. We don't want lead-ins for this. And we're going to make this a negative 0.00. Let's make it 7 thousandths deep. 0. And all this is okay. Planes, I know that that's not right because of where the linking parameters were. It's top. And I want to make sure my coolant is on. It is. Check. And you can see there, it actually has it in there. And I'm going to go and I'm going to check this one as well. All right, so it looks a little faint compared to the rest of this. So all I need to do to fix that, and this is why you verify it, because really I'm just kind of guessing otherwise what the depth needs to be. Oh, yeah. Negative 0.00, or actually near 0.012. We're going to almost double that and see how that looks. Might be a little too deep, I'm not sure, but we'll see. Oops, wrong one. That looks better. Yeah, that looks better. And I could even take that deeper if I wanted to. If I wasn't happy with it, I could make that even a little deeper. But that looks good enough for now. So let's go ahead and move on. Next part is not standard, roughed engraving. Okay, so for these, what I'm going to do is select them, and we're going to go to our toolpaths, and we're going to use engraving, but we're going to turn the roughing on this time. And reselect them. Don't take it if I do them ahead of time, I guess. And select tool from library. Okay, so I need to select a different tool here. And I'm going to select a 3/16 with a 30 thousandths tip. That's going to give me a little wider tip so that I can step over and rough it out quicker. So we're going to keep the same feed rate, 12,000 RPM, 10 inches a minute. There we go. And again, the planes aren't correct here, but this is going to be 0. Negative 50 thousandths is okay. This stuff is all right. Roughing, we're going to turn on roughing, and we're going to do a parallel spiral. And our step over is going to be 80%, which is 24 thousandths. That looks good. And I'm going to hit check. Let's see what it does there. So that looks pretty good. Looks like it's roughing most of that out. All right, now I've roughed it, but I still need to finish it. So, the other thing I need to do is go in and change this plane because I know it's wrong. 5-axis top, check. And you'll get it. If you don't change that plane, it'll do weird stuff when you machine it. So when I stick it in the machine, it'll start machining way up in the air, or it'll go places it's not supposed to go. So you know real quick when you forgot to change a plane to the correct plane. Okay, so next we're going to do another engraving pass, and again I'm going to select this stuff, check, and this time I'm going to select, oh man, I guess it's this in there, 60 degree by 1000. Okay, so I want to select my finishing one. Let's select that one. It's going to be 10 inches a minute, 12,000 RPM, 10 inches a minute. And let's get my plane right oil. Top. Check. Engraving. 0. 50 thousandths is good. Roughing, we're going to turn that off. Actually, we're going to leave that on. And we're going to pick remachining. And what that's going to do is it's going to look at the previous operation and it's going to see what didn't it cut out, what couldn't it cut out because of that 30 thousandths tip. And it's going to take this much smaller tip and it's going to kind of just whittle that away so that it gives you a perfect shape. So we're going to hit check. And you can see here where it does that. So it couldn't get in and actually do this area. You can see right here, this is where the 30 thousandths tip stops because this becomes too narrow for it. So it takes that little tool and it goes in there and it cleans all that out. And you can see it here, a couple of different places. It gets in these corners where that 30 thousandths tip just couldn't get. All right, so let's take a look at that. See how it looks. Now that looks much sharper. And here you can see, okay, I have a little bit sticking up. I don't like that. So to fix that, let me go in here and let me change this to clean corners and see if that makes a difference. It usually does. If that doesn't work, I can always reduce my step over. And that did work. So that gave me what I wanted there. All right, so what I'd like to do is I want to simulate this once without that finish pass and show you what it would look like. So I'm just going to exclude that finish pass. You can see the difference. So you can see here, you see how it doesn't go down to the depth and it's a little goofy right here, and you have really kind of clunky shapes. It's not real clear. The H doesn't look good. That's the difference. So that's why you have to go back and remachine that with a much smaller, skinnier tool. All right, so our engraving is done. Our holes are done. All we have to do now, and this is a rule of thumb for almost any manufacturing, my rule to my students is don't hand me a project unless you would give it to a baby to play with. Meaning, it should not have any sharp edges on it whatsoever at all. My background, I came from the entertainment industry, touring, so we would make staging for concerts and stuff like that. Well, it was extremely important to make sure there were no burrs on anything because the roadies that would go and set this stuff up would be touching it every day, constantly grabbing onto different areas to set it up. And, if there was a burr on it and it cut them, obviously you don't want that, right? That doesn't reflect well upon us as a company if we're providing them with stuff and it's cutting them up. So the same thing with any industry. Unless they ask for it to be a sharp corner, it should have a broken edge. You should break that edge so it doesn't cut anybody. So we're going to go through that and we're going to make sure that all the edges are broken. So I'm going to go back to my solid. I'm going to turn everything else off. I'm going to go to my plane 5-axis top and work completely on that to start out with. And I'm just going to chamfer this back edge here. So I'm going to go to top. And we're going to do a contour. And I'm going to do a partial loop. So I'm going to select that and to here. And that's going to give me my partial loop. Okay, and I'm going to hit check. Tool, select one from the library, 1/4 inch chamfer mill. We're going to go at 50 inches a minute, 12,000 RPM, plunge rate of 20. Rapid retract is on. Cut parameters, we're going to make this a 2D chamfer. I'm going to put wear on so that I can adjust this on the fly out of the machine. My chamfer width is going to be, let's put a heavy chamfer in. We're going to put about 30 thousandths on here. And our offset in the bottom, we're going to make that 20. Make that 25 just to be sure. Okay, depth cuts, no. Lead in, yes. So we do want to lead in. Adjust the start of the contour. I'm going to make this maybe 25%. And I'm going to move that over. All that does is it just adjusts the length. So rather than starting right here at this corner, it'll start out here a little bit further. And that's just to make sure that you don't end up with kind of like a little bit of like a scalloped edge there because you're using a round tool. It's not perfectly at that corner. Okay, so that looks good. Depth is 0. Top of stock is going to be 0 as well. All this stuff looks good. My coolant should be on. It is. And you can see there my tool path is created. Now the depth, since I kept it at 0, that's actually formed by the chamfer width that I put in. All right, so the next one I'm going to do is the back. So we'll do one more, and then I'll fast forward through these like I have in the past because it's just repetitive. So I'm going to go to planes, and I'm going to go to back, bring these two down, and we're going to go contour. And I'm going to do, in this case, I'm going to do edges. I'm going to select that edge, end it, and I'm going to select this edge, end it. I don't need to do this edge because I've already done it. So there's no reason to re-machine this edge. I mean, I could, it wouldn't hurt anything, but it just saves a little bit of time. I'm going to hit check, tool, same depth. Everything here should pretty much be exactly the same. All this stuff is already set. Top of stock, however, should be 0 because we've machined that away now. So it's the only thing I should have to change in most of these. Planes, coolant's on, check. Okay, looks good. All right, so I'm gonna burn through these. One thing that doesn't look good here, you can see it's off to the wrong side. So I do need to change that. Yeah, so actually what I need to do is I need to reverse because I want to climb mill these. I actually need to reverse my chains. Reverse and reverse. I selected them in the wrong order. That's my fault. Okay, so now you can see they're to the outside, so that looks good. All right, so now I'm going to fast forward through these and go ahead and finish up. Okay, so they're all finished up. We have all the edges chamfered. Now, one thing I need to do yet is just chamfer these holes. So I brought you back to show you that. We're just going to do a contour again, just as we did before. This time I'm going to pick a loop, and I'm just going to select all of these holes. I can reverse the direction of this. I actually want to climb mill, so I'm going to go counterclockwise. That way I climb mill. Okay, check. Tool is the same. Everything here is the same. I'm actually going to slow this down because it's such a small diameter. I'm going to slow this down to about 25 inches a minute. Wear is on. We're going to do a 3D chamfer. I'm actually going to make this 0.05. I'm going to make this a bigger chamfer just because it's a lead-in for a pencil. Depths, no. Don't need to adjust the contours on this one, so it'll just overlap itself. And linking parameters, that's going to be at 0. Planes, 5-axis top for all of those. And hit check. Okay, so they look good. Now, you may have realized that I did the top already and then I came back to the top. So I don't really like that. I want to do everything on the top at once. And that was just an oversight on my part. Just forgot. So what I'm going to do is I'm just going to drag this up to right underneath our contour or even above our contour. It doesn't really matter. as long as it's on the same. So now I have 5-axis top, 5-axis top. And then this one here, you can see 5-axis back, right, and left. All right, so let's run this. Everything should be good, but we'll be able to see if it's not. And there we go. So there is our part. And I can see it doesn't go the whole way down. It doesn't need to because we're going to mill that material off anyway. But we have all our chamfers on it. And we'll put the chamfer on the bottom when we mill the material off. In theory, I could actually run a chamfer groove through there and then just mill it off. But since I already have to mill that operation anyway, I'm going to do that after I mill it off. So that looks good. All right, so we're going to close this out, and I'm going to post this code. And hit save. Yes, I want to replace it. And our code should come up here. And this is what our code looks like. You can see our M&G code here. And you can see our axes of movement here as well. So we have an X, a Y, we have a Z here, and then you have an A and a C here. So altogether, that's 5 axes of movement. You can see here it actually goes to A90. That's when we do the back. So it's moving 90 degrees in the A, and then it's going to mill the back off. So we have a pretty long amount of code here, and that's just because of the engraving. Engraving takes a long time. There's a lot of code for the engraving because it's using 3 axes simultaneously to create that depth with a tapered tool. Yeah, and that's essentially it. So that is how we create the program for this. Now, one thing about this is, remember, we still need to hold on to the bottom of this. And we actually run a dovetail program to hold on to the bottom. And this uses a special kind of code called a macro code. It doesn't have to. I could program it in here just like normal. But I don't. And it's because by using a macro, what I can do is I can create one program. I can give it certain pieces of information, such as the width and the length and the depth of the dovetail. And it can put a dovetail in any part of any size, anywhere on the part, centered. So it's advantageous to create a macro program when you know it's a program that you're going to be using. Essentially, the form of the program is going to be the same. It just may vary in width. It may vary in length. It may have just a few variables. But the overall form is just going to be scaled up or down. So what I can do is I can actually bring the macro program up. Hopefully I can find it. Just to give you an idea of what it looks like. And this isn't the exact program that I'm going to be using out there. I've actually edited this program further. This is an old version of it, but this is the one that came up, so we can take a look. It'll give you the idea. So what I'm going to do here is this program is actually using calculations. So if you've ever used a ProtoTrack or something like that, basically that's how they work. You give it parameters. So basically what I'm telling it is, if I put an X value in of 4 inches, I'm saying that the width of the part is 4 inches in the X. Whatever the dimension is in the Y, the width of the dovetail feature that I want to make, the depth of the dovetail feature, the tool number that I'm going to use to to rough out for the dovetail depth, the dovetail cutter tool number, the material, and this just determines what my speeds and feeds are. It automatically calculates all those. And my fixture offset. And I have some other ones that I've further, like I said, this will only do an external dovetail. I have the one I use out there actually creates an internal or external. So there's a few more variables in there. But essentially, all I'm going to do is call up what is a G65, the P value, which is this program number, and then I enter X and whatever those numbers are each time. And I'll demonstrate that out of the machine. But just looking at this quickly, you can see that these are all equations. And these pound 8, they're just, the pound values, they're just placeholders for data. This is just data. This is just telling it the width. And subtracting the cutter diameter here, like pound 2000 or 2400 is the width, diameter of that cutter that it's using. And I just know that because obviously I've been using these for a long time. But yeah, it's a different kind of program. So it basically uses M&G code combined with BASIC programming language. But it's extremely useful. It's really great for doing families of parts and things like that. So let's head out to the machine and I'll show you how we dovetail it, and then we'll head over to the 5-axis and we'll run this part in the 5-axis in part 2 of this video.